Hey guys, have your notes pulled up for section 4.3 day 1, and we're going to kind of get away from the angles on a graph just for a couple of days. We're still looking at angles, but this time we're going to focus on angles in a triangle. And so really this whole page of notes is just a refresher from geometry. You learned all of this in geometry and probably did some of it in Algebra 2 as well. So this is just a reteaching of a couple of sections in geometry. So we're going to be, the main thing you need to remember today, so important, is that the three angles of a triangle always add to 180. No matter the size of your triangle, no matter the shape of your triangle, your three angles always add to 180. Now today, the triangles that we're looking at are right triangles. So one of your angles is going to take up 90 degrees of that 180, which means you only have 90 degrees left for the other two angles combined. Therefore, the other two angles in a right triangle are always going to be complementary. Alrighty, so we're going to start super easy. We're going to start creating fractions. You're just going to write fractions on your paper, but I'm often going to call your fractions ratios because I don't want you to just think of them as a fraction with a numerator and a denominator. I kind of want you to think of them as a comparison of two numbers. A ratio is a comparison of two numbers. Okay, so let's get started. In order to set up our sine, cosine, and tangent fractions, we need to kind of get acquainted with our triangle. So you can see that all of these are all about the angle that we call theta. And again, theta is just a variable that we use for an angle. Just like we use x in our equations a lot and y, we use an x and a y, usually is in an ordered pair. We usually use theta as a variable for an angle when we're working with trig. Not always. Sometimes we could use an x, but most of the time we use theta. So, it doesn't matter where theta is, but I think your triangle is set up to where theta is down here. So once you've identified the angle that we're looking at, now get acquainted with your triangle. Obviously, the side across from the 90-degree angle must be your hypotenuse, no matter what. That's always the longest side of your triangle. If this is what the location of theta, see this leg right here? The two legs are what make up the 90-degree angle. This leg actually touches your angle theta. It's the side right next to it, so it's the adjacent side. I'm going to abbreviate and label it like that. It's the adjacent side. Just like if you were sitting in my classroom and you had a partner sitting at a desk next to you, we could say that that person was sitting adjacent to you, right next to you. And then if you look at the other leg, the leg that's across from theta, that's the opposite side. All right, so to make your sine fraction, we're going to abbreviate the word sine with SIN, and every single time you write SIN, immediately following it must be the angle. You can use the variable that represents the angle, or you can use the measure of the angle, which we don't know. So we're going to use a variable to represent it, and we create our fraction by taking the opposite side length. We take that number and we put it over the length of the hypotenuse. So a sine fraction is actually a comparison of this length to this length. Cosine, this is the abbreviation, has to have the angle behind it, either the variable that represents it or the angle measure. We don't know the angle measure, so we're going to use the variable. It's the adjacent over the hypotenuse, this length over this length. And tangent, don't forget the angle has to be behind your abbreviation, opposite over adjacent. This length compared to this length. These all have to be memorized. And one way that you can memorize them, you may have seen this before, it looks like an Indian word, it's SOHCAHTOA. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Good way to remember how to create those three fractions. Now, let's look at the other three trig ratios. They are cosecant, secant, and cotangent. If you can see that cosecant, this is what its abbreviation looks like. Secant, this is what its abbreviation looks like. Cotangent abbreviation. There are two ways to obtain the fraction that you need, or the value that you need for these three. The first way, if you already have these fractions written on your paper, all you have to do to get your cosecant is simply take your sine fraction and turn it upside down. That's all you got to do. To get your secant, if you already have your cosine, take your cosine fraction and turn it upside down. To get cotangent, turn your tangent upside down. Now, what's this for? This looks a little more complicated than just simply turning a fraction upside down. This is for, you know how fractions aren't always written as fractions? Sometimes a fraction can be represented in decimal form. So sometimes this might not look like a numerator over a denominator. This might be a decimal. How do you change this decimal into the upside down version of it? You do 1 divided by your decimal. 1 divided by your decimal. Alrighty, these have to be memorized. How are you going to memorize these? Well, the way that I remember them, obviously the cotangent goes with the tangent. This is the upside down version. How are you going to keep straight that this one is the one that goes with cosine and this one is the one that goes with sine? Here's the way I remember it. None of your cos are paired together. CO. None of your cos are paired with each other. So this co is not paired with a co. This co is not paired with a co. This co is not paired with a co. No co's go together. Good way to remember those, okay? One more thing. Reminder, when you write this abbreviation, no matter which one you're doing, the angle has to follow it. We're going to be so picky about that. And if you don't write it correctly, you're actually going to get points deducted on like a quiz or test if you don't write it correctly. The other thing is, when you talk math or when you think math verbally in your head, as you're writing this on your paper, I don't want you to think tan theta equals cos theta equals sin theta equals. When you say it, you say the whole word. You write the abbreviation. So I write sin theta. I say sine of theta. I write cos theta. I say or think to myself cosine of theta. Right? We say the whole thing. We're not going to say sin, cos, and tan. Math is not a sin. Cos is, I don't know, and tan's a color. We're not going to say the abbreviations. We're going to say the whole thing. Okay? All right, let's make some triangles. Let's make some fractions. All right, so I think your triangle is set up the same way as mine, and we are needing, in order to do this problem, we need to write the sine fraction for theta, the cosine fraction, and so on. So in order to write the sine fraction, here's theta. Get acquainted with your triangle. This is the adjacent side. I'll go ahead and label it adjacent. This is opposite. And this is hypotenuse. To make your sine fraction, I'm going to grab the opposite side length, which is 2, and put it over the hypotenuse, which is, oh shoot, I don't know. That's okay. It's a right triangle, and in a right triangle, to find a missing side length, you can always use Pythagorean theorem. So we're going to set up our Pythagorean theorem. Remember, the hypotenuse is what goes on the side by itself. So you can see that I've set up Pythagorean theorem. I said this leg squared plus this leg squared equals, and I just called it something kind of random, my hypotenuse squared. Okay? Square that, square root both sides. My hypotenuse is actually the square root of 7. And I'll just leave it like that. There's no reason to turn it into a yucky decimal. So my sine fraction is going to be opposite, which is 2, over hypotenuse, which is radical 7. And that's almost good enough, but you know that you can't have a radical in your denominator. So that has to be fixed. No big deal. Y'all can fix that. There you go. There is my sine fraction, and it's a comparison of the opposite over the adjacent. No, sorry. It's the opposite over the hypotenuse, my bad. All right, cosine, I'm going to grab the adjacent, which is radical 3, over the hypotenuse, which is radical 7, and that's going to need to be fixed also. The 3 is under, the 7 is under. Therefore, you may multiply them together, and I get radical 21 over 7. That's my cosine ratio. And tangent is going to be opposite, which is 2 over adjacent, which is radical 3. Fix it. Outside, inside, not allowed to multiply. So it's 2 radical 3 over 3. There you go. There's your tangent fraction, your tangent ratio. Now, let's work on the other 3. Now, it says it's got this written, but again, what I said was, if you already have your fractions made, just simply turn your fractions upside down. So, ready? To get cosecant, let's turn our sine fraction upside down. But wait, you have 2 to choose from. You have the original fraction that you made, which was correct. It had the right value. It just wasn't written properly because you had to get rid of the radical on the bottom. So this improperly written fraction is the same as this properly written fraction. Which one would you rather turn upside down to get your cosecant? If you turn this one upside down, you're going to end up having a radical in the denominator and you have more work to do. Well, this one's the same thing. Would you rather turn this one upside down? I would. So I'm going to turn that one upside down. I get radical 7 over 2. Easy. Let's skip down to cotangent because that one's going to be the same. Ready? Cotangent. Do you want to turn this one upside down? Or do you want to turn this one upside down? I'd rather turn this one upside down. Radical 3 over 2. All right. Secant. So I got to turn cosine upside down. I can turn this one upside down, radical in the denominator, or I can turn this one upside down, still a radical in the denominator. It's your call. Some of you might choose this one because there's only one radical. I'm going to choose this one because my numbers are smaller. So I get radical 7 over radical 3, and I'm going to fix that. I get radical 21 over 3. Okay? Simply making ratios. Next, this is going to be the same type of problem. It's still asking for sine, cosine, and tangent. But in this case, you have to set up your triangle. The numbers aren't given to you as obviously as up here. You have to set up your triangle. So the information that you have is that your cotangent fraction is this, which means your tangent fraction is the upside down version. So here's what I would do. I would go to my triangle. I'm going to look at where theta is. I'm going to identify the opposite side and the adjacent side, and I'm going to write 2 on the opposite side, and I'm going to write radical 3 on the adjacent side. So if this is where theta is, and it really doesn't matter where you put it, as if you're the one setting up your triangle, it doesn't matter where you put it. Put it somewhere. Label your opposite with 2, label your adjacent with 3, and label your hypotenuse with whatever you get when you do the Pythagorean theorem. But we already did the Pythagorean theorem, so. All right? And then again, it's just a matter of creating your fractions, which this turns out to be the same problem as the one above it, so I'm not wasting my time. Okay? We are coming up with sine, cosine, and tangent fractions. But remember, fractions can be represented in decimal form. Keep that in mind. Let's go to the back. You're going to need your scientific calculator. If all you have is your graphing right now, that's okay, but keep in mind for this upcoming test, it's going to need to be scientific. So I've got my scientific calculator. I'm going to make sure I'm in degree mode. If your scientific calculator doesn't say DEG down at the bottom, it might say RAD. Well, you're in radian mode. You need to get out of radian mode. So to switch modes, it's right beside your second button, and it says DRG. Degrees, radians, gradians. And you can switch back and forth. So push that button, highlight degree, hit enter. You're going to be in degree mode. Ready? So, I don't have a picture. I don't have an opposite length and a hypotenuse length to come up with my sine fraction. So what I'm going to do is I'm going to use my calculator and say, give me the sine fraction for a 27-degree angle. So I type that in my calculator and I hit equals. And it gives me my fraction, but it's in decimal form. So it gives me, and it says go to, does it say go to? No, we're going to go to 4 places. 4, 5, 4, 0. Tangent. For this angle, I don't have a picture, but I have a calculator. So I'm going to go tangent, 45 degrees. Ooh, that was nice. That's my fraction. That is how the opposite and the adjacent compare to each other. Secant. We don't have a secant button. Slight problem. How do you get secant? Well, 2 ways. How do you get secant? You can take your existing cosine fraction and turn it upside down. We don't have an existing cosine fraction in this problem. So if we don't have a fraction to turn upside down, how about we do this instead? To get secant of this angle, let's do 1 divided by cosine of that angle. I'm going to do 1 divided by cosine of 68 degrees. Type that in your calculator. And I got 2.6695. Alrighty, now here's what's cool about this. It doesn't matter how big your triangle is. You can draw it on a piece of paper, or you can take a sidewalk chalk and go out to the parking lot and draw a huge triangle. If you draw a triangle that has a 27-degree angle with a piece of paper or in the parking lot, your opposite to hypotenuse comparison will always compare like this. Always. Let me show you something kind of cool. I drew this triangle kind of freehand, and then I kind of took a protractor and measured it. And what I got was this angle was 57 degrees, and this angle was 33 degrees. And they add to 90. So yeah. Now I'm gonna copy this triangle. Paste it, shrink it. Okay? Now, even though this triangle is definitely smaller, You know how these three angles add to 180, right? These angles are the same. They still add to 180. This is 57, so is this one. That's 33, so is this one. That one's 90, so is this one. So the angles stay the same. The side lengths are definitely different. So here's what I did. I went and measured these lengths right here. And I got on my little iPad, this was 15.9 centimeters. And this was 10.3. Oh gosh. And at the time that I did this, when I copied it, this one was 3 and this one was 4.63. When I was playing around and measured everything, okay? That's how it turned out to be. Now, watch. Let's look at our 57-degree angle. So focus on this one. Look at our 57-degree angle. If I want to do my sine fraction for this angle, again, I didn't call it theta because I knew its measure. So sine for that angle is, no, I don't want to do sine, I want to do tangent. I don't want to do any extra math. Let's do tangent. Let's do tangent for this one because I've got 15.9 and 10.3. Does that make sense? Opposite side length, adjacent side length. If I do that math, 15.9, 10.3. 15.9 divided by 10.3. I get 1.54. 1.54 is how my opposite and adjacent side lengths compare to each other. How about over here? This time my opposite is 4.63. My adjacent is 3. I wonder what that equals. 4.63 divided by 3. 1.54. This triangle is obviously smaller than this triangle, yet they still have that 57-degree angle, and my opposite and my adjacent sides still compare in that same ratio. Wonder what my calculator tells me tangent of 57 is. Tangent 57 degrees. According to my calculator, tangent 57, 1.54. You gotta admit, that's kind of cool, right? Opposite and adjacent for a 57-degree angle will always compare in approximately, and I had to round this ratio. That's pretty cool. All right, now, coming back to where we were, I'm going to try to get through these quickly, but oh my gosh, this is so, so crucial. Let's look at sine, cosine, and tangent for our common angles. Remember our common angles that I had you do on that sheet? The common angles in quadrant 1 were 30, and then 45, and then 60. So, if I'll take you way back to geometry again, let's look at a 45, 45, 90 triangle. So, we got our 90-degree angle. The other two angles are 45 and 45, which means, you know what? It's not only a right triangle, it's a right isosceles triangle, which means my legs of the triangle are congruent. And then, if you think, again, think back to geometry, whatever this measurement is for this side length, whatever it is, I'm going to call it X. Guess what this measurement is? Of course, it's X. And then, remember geometry. Do you remember how to get from a leg to the hypotenuse in a 45, 45, 90. There was a shortcut. Yes, you can use Pythagorean theorem, or you can say your hypotenuse is this times the square root of 2. The leg length times the square root of 2. Ready? This can be anything. This has to be whatever this is, and this has to be whatever this is times square root of 2. Let's make some fractions. Even though I don't have any actual values for my triangle, let's make some fractions. This is going to be cool. Here we go. Sine 45 degrees. Pick one. I don't care which one. Pick a 45-degree angle. Let's do opposite and hypotenuse. Opposite over hypotenuse. What's going to happen to your x's? They cancel. And you're left with 1 over the square root of 2, and then you have to fix it. And you get the square root of 2 over 2. This is how your opposite and your hypotenuse compare when you have a 45-degree angle in your triangle. It doesn't matter what. This could be 11, 11, 11 radical 2. This could be 8, 8, 8 radical 2. And your sine fraction will always be this. I kind of like how the x's cancel out. Cosine 45. Let's do adjacent over hypotenuse. Oh, look. I think we're going to get the same thing. We are going to get the same thing. You get the same thing for sine and cosine when your angle's 45 degrees. Ponder that for a minute and see how that's possible. Tangent 45, let's grab tangent. Opposite over adjacent. That's cool. Wait a minute, have we seen that before? We have seen that before. Cool, huh? All right, moving on. Oh, so recap. Sine fraction, cosine fraction, tangent fractions for one of my common angles for 45 degrees. All right, let's look at a 30, 60, 90. In order to come up with a 30, 60, 90, I've started you off with an equilateral, which means 60, 60, and 60. Now, let's drop an altitude and cut that triangle in half. Now, this angle up here is now 30. So I just want us to focus on this triangle and leave that one out of it. So let's just look at the triangle that's blue on one side and black on one side and black on one side. 30, 60, 90 triangle. Ready? Hypotenuse, leg, leg. This is obviously the shorter of the two legs because it looks that way and it's across from my smallest angle. I'm going to call this the short leg. I'm going to call this the long leg. And obviously I'm going to call this the hypotenuse. Everything revolves around the short leg. Let's say I call the short leg X. Let's say I call this just from here to here. Let's say I call that X. What's this whole side then? And so is this one. So if this is X, then this hypotenuse is 2X. Now, do you remember how to go from the short leg to the long leg? Again, geometry. You had it memorized at one point. It's your short leg times radical 3. Short leg times radical 3. Okay. Now, this is asking us, let's do sine, cosine, and tangent for a 30-degree angle. So look at this angle. Let's do sine, opposite hypotenuse. Oh, that's nice. Let's do cosine adjacent hypotenuse. That's not bad. And let's do tangent, opposite adjacent. That one's kind of yucky. It has to be fixed. I got radical 3 over 3. Okay? Sine, cosine, and tangent fractions for any 30-degree angle. And what's cool about this, it doesn't matter what this is. This could be 7. This would be 14. This would be 7 times radical 3. This could be 52. This would be 104. This would be 52 times radical 3. All right, now let's focus on our 60-degree angle. So now let's switch to this one. Here we go. Sine fraction, opposite hypotenuse. I've seen that before. Cosine, adjacent hypotenuse. That's nice. Seen that before. And tangent, opposite adjacent. That's not bad. Alrighty. Sine, cosine, and tangent fractions for all 3 common angles. Now, I'm going to say something, and it's going to sound intimidating, but hang on for a minute. All 9 of these fractions, we're going to ask you to memorize all 9 of those fractions. And I know it sounds totally intimidating right now, but it doesn't have to be done for another, I don't know, several weeks. Don't start doing it right now. You don't have to start making flashcards and doing all that stuff. We'll show you several cool ways to memorize them. And you'll be kind of amazed on how quickly you'll be able to come up with all 9 of those fractions. I just want to throw that out there because it does. It sounds intimidating that you're going to have to memorize those, but it's not going to be as bad as it seems. Okay, lastly, let's get through this really quickly. Cosine of an angle is 1/2. The cosine fraction of an angle is 1/2. What was the angle? Well, I think you're going to find all of these on this paper. So look up here. Do you see anywhere up here where we wrote a cosine fraction that was 1/2? It was right here. What was the angle? It was 60 degrees. So therefore theta, 60 degrees. How about sine? Did we write a sine fraction that was radical 2 over 2? Did we write a sine fraction that was radical 2 over 2? Yes, we did, right there. What was the angle? It was 45 degrees. Oh, nope. I wish, but nope. So the angle is 45 degrees. Cotangent. Did we write a cotangent fraction that was radical 3 over 1? I never wrote a cotangent fraction. Okay, well, if the cotangent is radical 3 over 1, the tangent would have been 1 over radical 3 before I simplified it. Did we write that anywhere? 1 over radical 3 before I simplified it? Yeah, right here. 1 over radical 3, and then we simplified it, 30 degrees. 30 degrees. So what we did is we looked up here to see where is my cosine fraction 1/2. That's how we found our answers. All right. Sorry, guys, that was a long video. Hope it helps. Good luck.